Class, this is your another practical regarding capacitance of a capacitor using flashing quenching of neon lamp. Now here, whenever we supply any power supply, DC power supply to the capacitor, when capacitor get fully charged with the help of power supply, it will transform the flow of charge carriers to the neon lamp, and with the help of that charging of the capacitor, we can get the flashing and quenching of neon lamp. So here for that purpose there is a DC supply which is supplied to the capacitor. Capacitor get fully charged with the help of this power supply, and the motion of charge carrier we can study on the edge where flashing and quenching of the neon lamp is going to be measured. So for this case there is the observation table that I will discuss with you after showing the circuit diagram. So class, here is the circuit for the flashing quenching of neon lamp, and here is the voltage supply, DC power supply, and with this point I can on the switch. With the help of this I can see here neon lamp to be flash the light. This is how we can flash the light, and this is unknown capacitor whose capacitance is going to be find out. Now first of all, this is how I have switch off the whole capacitance. Only 1 ohm capacitance is to be used. So along with 1 microfarad capacitance, I will use this unknown capacitor like this. So this is how we can calculate, we can measure the time period for this 20 flashes on off. For 20 flashes we will count the time period. Okay, this is how I have joined this unknown capacitor, and with the help of this capacitance 1 microfarad I can equate the time period for this 20 flashes. This is for the first case. If I switch off this and this also, this is how only C2 is on now. This second capacitance is on, 2 microfarad. Okay, so with the help of this I can again get 20 flashes. Along with that I will equate the time period, that how much time period is required for 20 flashes to be proceed. Okay, so third one is for 3 microfarad. I will again trace the time period. Okay, this is the one case. Another case is that when I just on 2 switches, this means total capacitance is of 1 plus 2, 3 microfarad, and with the help of that 20 flashes again I will count for the time period. For 20 flashes, what is the time period that I will count? Similarly, for 3 plus 2, 5 microfarad, I can again count the time period for 20 flashes. Okay, this is how we can proceed. Now, if I take only 3 microfarad and I just remove this unknown capacitance, that means this is the case without Cx, without unknown capacitance, 20 flashes are there. When I switch off again 2 on means 20 flashes again I can count, and this is without any capacitance, without any unknown capacitance. Okay, and this is the third case for 1 microfarad. So this is how firstly you will proceed for with unknown capacitance, means you will just connect this along with this, means unknown capacitance is connected. Along with this 1, 2, 3 microfarad you will use one by one. 20 flashes you will count along with the time period. Same for 2, same for 3. 20 flashes we will count. After that we remove it and count 20 flashes. So this is how 20 flashes you can count without capacitance, without Cx. So this was your practical, and now I will go for the observation table. Then I will show you that how you will trace the values there. So here is the observation table. Unknown capacitance is that capacitance which I just add. So unknown capacitance, at the place of unknown capacitance you can write. So this is how you can calculate for the unknown capacitance. 1 microfarad with the value of 1 microfarad unknown capacitance, you can get the value of 20 flashes. So mean of that 20 flashes you can just divide 0.22 by 2, that is 0.11. So half of that time period is flashing quenching time. Similarly, time for 20 flashes and so on.